Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right. All right. Looks like everyone is in. Good morning. Good morning. All right. So, of course, my notes not popping up. All right. Good morning. Good morning. Good morning. All right. So today we are getting into chapter 4. Wrong one. Well, somebody dropped the Happy Lunar New Year on us. Okay, Happy Lunar New Year. Most definitely, most definitely. So we are visualizing variability with a scatter plot. Let's see what's going on here. Sorry, try to make this stuff a little neater. That's good enough. All right, so scatter plot is a primary tool for examining two variable relationships when both variables are numerical. Each point represents one observation. So over here is just a generic representation of a scatter plot. If you remember your Cartesian coordinate plane, when you have your X and Y axis, we're just using the first quadrant over here for the scatter plot. So when studying scatter plots, we look for three things. One is trend, which is your center. The other is the strength, which refers to the spread of your data. And then the other is your shape, which is just your shape. So we're going to talk about all three of those things separately. Let's scroll up. So the trend is the general tendency of the scatter plot as you scan from left to right. So you always try to read your graph from left to right and look at patterns from left to right. As always, if I scroll up and you still copying, feel free to mention it in the chat or unmute. See something real? Yeah, I got it down here. Okay. So increasing trends are called positive associations or positive trends. Decreasing trends are called negative associations or negative trends. All right, can I scroll up further? All right, so below we have just 4 generic examples of types of trends that you could see. If you go from left to right and your pattern is going up, that's considered having a positive association. If it's going down, that's a negative association. It is possible to have no trend at all, so you don't see any type of pattern. Or you could have a changing trend where it can go from down to up or something like that. In other words, there is a pattern, but it doesn't stay the same. Or there is a trend, but it doesn't stay the same. Scrolling up. Okay. Next is strength. So weak associations result in a large amount of scatter, talking about a large amount of scatter in your points. So something like this is considered having a weak association. Large amount of scatter means that the points have a great deal of spread in the vertical direction. Strong associations have little vertical variation. All right, and then here, once again, just a generic example as to how these associations could look when it comes to these plots and these points. The more they are together, the stronger the association. The more they are apart, the weaker the association. All right. Last one is the shape. Last one of those 3 anyway. Shape, the simplest shape for a trend is linear. And that's the one we're going to focus on. Linear trends are quite common in nature. They always increase or decrease at the same rate. And they are called linear because the trend can be summarized with a straight line. All right, scrolling up. All right, so linear trend versus nonlinear trends. So like I mentioned, this book and what we're going to do is we'll be focusing on linear trends. All right, can you scroll up? All right, so we're going into 4.2 now. So you can copy that title, and then I have to go to another page. But it's measuring strength of association with correlation. So don't copy, the red and purple. That's just notes for myself. But I just copy the title, and then we'll switch to another page. Copying linear examples. Okay. Let me know when you're ready. Not a problem at all. So let's go to correlation coefficient. So our linear correlation coefficient is a measure of strength and direction of the linear relation between two quantitative variables. So we talked before about how population and sample has two different sets of symbols. So the same thing happens here for our correlation coefficient. We have Greek letter rho for the population correlation coefficient. It's like the P, like baseball from the Philadelphia Phillies, kind of looks like that P. And then we have the regular letter R for the sample correlation coefficient. And that's the one we will be using. All right, so just like the instructions I gave you before for your standard deviation and your variance, we're going to use a calculator website or app to find the correlation coefficient or the regression line. So let me erase this. So the correlation coefficient is 4.2. Regression line we'll talk about in 4.3. And just like I suggested before, easycalculation.com can find both of those. I'll show you in a second how that works. All right, let me scroll up. I'm done with that black. Okay, so let's look at the properties of correlation coefficient. It is between -1 and 1 inclusive. That means it can be -1 or 1, but also everything in between. All right. So if R is +1, then a perfect positive linear relation exists. If R is -1, then a perfect negative linear relation exists. Everybody holding on to blue? All right, so the closer R is to +1, the stronger the evidence of a positive association. The closer R is to -1, the stronger the evidence of a negative association. Now, your correlation coefficient, and we'll talk about this more as we use it, only applies, and notice the terminology linear. So it does not help you figure out if there is another type of relationship or another type of pattern or trend. It only helps you in determining if you have a linear relationship or a linear trend. Number 6, if R is close to 0, then little or no evidence exists of a linear relation. And in the red, it goes back to what I was saying about this does not have anything to do with determining if it has a relation or not, just no linear relation. So R close to 0 does not imply no relation, just no linear relation. Then 7 and 8, it is a unitless measure of association. And then 8, it is not resistant. So that means it is affected by outliers. All right, can I scroll up? So below I have just a few generic examples as to what R being equal to 1 means and stuff like that, but don't want to go up too far as far as those who are copying are concerned. Anybody holding on to 6? All right, so here, the first one is the perfect linear relationship, perfect line, R equal to +1. As you go from left to right, it goes up, and it's a perfect straight line. As you deviate away from that line, as points begin to spread out, it moves further and further away from 1 and goes closer to 0. So that's what we see here at 0.9 and then 0.4 as well. There's a lot of spread of your points, but you can still see that there's a positive trend. The fourth one, negative straight line, that's a perfect negative linear association. And then same type of deal. If it starts to deviate from that straight line, then you start to go closer and closer to 0. That sixth one, R is close to 0. Notice there is a pattern there. It's just not a linear pattern. So R is going to be close to 0. And then the same thing happens for that last one. There's no pattern at all, but R is still close to 0. Any question? All right, anybody still copying? You can go to the next page. Everybody go to diagrams, correct straight. All right. All right, so we're starting right here. Correlation does not mean causation. Still in 4.2. We're just finishing it off. So do not conclude that a cause and effect relationship between two variables exists just because there is a correlation, no matter how close to +1 or -1 that correlation may be. So once again, correlation does not mean causation. And we'll look at an example of that in a second. All right, example of what this means. A politician wants to close down liquor stores in the city because there was a positive correlation between the number of liquor stores in the neighborhood and the amount of crime. So we have a rebuttal to that in a second, but just give me a chance to write that down for those who are writing it. Anybody still holding on to black? All right, so red is a response to the statement in green. Even a correlation near +1 is not enough to conclude that changing one variable, the liquor stores, will lead to a change in the other variable, crime. So in other words, even though you may see the correlation of, a +1, that every place that you look, there's high crime, there's also liquor stores, but there may be other variables that play a role into that. Like, is there a shopping center nearby? What about gangs? There's a whole bunch of things that could play a role in that. So you cannot just assume that if you take out all liquor stores, then crime will, just go down. So. All right, the next one is the correlation coefficient in context. And next example is the correlation between the number of Google searches for zombies and vampires is 0.924. All right. So this means that those who Google search zombies also tend to search vampires because R is positive and close to 1. So there's a positive association. If it was a negative association, it was close to -1. Then those who Google search zombies would not tend to Google search vampires. Any questions? Any questions? All right. So find the correlation coefficient between the club head speed of the golfer and the distance the ball travels. So we're talking about a golfer here. Is everybody done with the red before I keep going? Can I scroll up? Okay. So we're talking about a golfer here. And the club head speed, we're talking about the head of the golf club and how fast he's swinging it. And then as he hit the ball will travel a certain amount of distance. You see in the green, I label that club head speed explanatory variable. The distance the ball traveled is the response variable. And we'll talk about that in more detail. I think it's in 4.3, but I was just giving you, a heads up as to what they are called. The explanatory variable will explain the response variable. The response variable responds to the explanatory variable. So in other words, I swing the golf club and the ball travels a certain distance as a response to how hard I swing the club. So we have 100, 257, 102, 264, 103, 274, 101, 266, 105, 277, 108, 263, 99, 258, and then 105, 274. And notice that these are not 16 separate instances. These are 8. That's one observation, second observation, third observation, and so on. So there's only 8 observations. He swung the ball 8 times, got 8 distances, separate distances. Oh, let's go right here, 8 observations. All right. Can we go to finding it? Everybody good? All right. So why's my page not showing? So I would go to Google and correlation coefficient, easy calculator or easy calculation, either or. Hit enter. And the first one pops up, correlation coefficient, easy calculation. All right, so here we have our X and Y values. In other words, our explanatory variable, response variable. We'll talk about, like I said, the difference between the two more in a few. But here you can add or take away your rows. All right, so let's plug in these values. And so if you, whatever app or website you choose, if you're doing more than just typing in data values and hitting enter, you're doing too much. This is all you should have to do. You shouldn't have to store values and program anything, pull something from anywhere else, because there are a lot of free things out here. And might as well take advantage of the free stuff. You just have to make sure it's reliable, because when it's free, most of the time, a lot of times you do get what you pay for. I won't say most of the time, a lot of times. But I know easycalculation.com is reliable. And there are some things out there that are real good. You may have to pay for it, but that's up to you if you want to pay money for it. But I'm not requiring that you pay any more money. All right, so there we go, 0.9386958 and so on. So MATLAB, of course, will let you know how many decimal places they want. So sometimes they ask for 3, sometimes they ask for 4. Also be careful, go back and reevaluate, not reevaluate, but review the values you plug in, because removing or being off by 1 digit. So if you go from 275, let's say 276, just one, notice it changes the value altogether of your correlation coefficient. So the formula is that sensitive. So make sure that you do go back and review and plug in your values properly. And so that will change it. So let's go back. But any questions on that before we go back to the notes? Everybody okay with what we did here? All right. So that's how I got that value right there. Any questions? Any questions? All right, let me see how long it's for. 3. I don't think it's right. Yeah. So that's sections 4.1 and 4.2. As I've been trying to tell you guys before, I try to pace us and try not to do too much in one day or have all of our stuff knocked out. And then we'll be looking at, when we're in chapter 10, it's only half of the semester to go. So it's still got half of the semester left. So we're going to pause right here. That's 4.1 and 4.2. Next class, we'll do 4.3 and 4.4, and then we'll be done with chapter 4. So you can see that these chapters and these sections aren't, a lot, unless we sit here and try to make it a lot. So like I said, we're going to pause right here before we close out today. Any questions? Questions on anything?
Can I talk to you after everyone leaves?
Absolutely not, sir.
Oh,
Not a problem. Not a problem.
I appreciate you.
Yeah. All right. Somebody said something about the R charts. Well, excuse me. So I'll say this. If you're done, then I'm done for today. Somebody wanted me to go back to the charts. So I'll make sure I got that person straight. But if you copied everything and you're good to go, then I will see you in next class. Be safe and take care. All right.
Thank you.
Yep, no
Thank
problem.
you.
Thank you. Thank you. The R charts. Are you talking about the graphs? Let me know what you need from me. Let me see. Yep, no problem. Take care. All right, take care. Have a good one. Yeah, 7 graph. Oh, okay. Hold on. I think I'm talking about right here. Okay. Yep, not a problem. Let me know when you're finished. Mr. Dennis, did you want to wait for as a personal, wait for everybody to leave, or did you want to go ahead now?
No, no.